Problem 9 is a compound interest problem. So I pulled up the compound interest formula here, which we can go through before we start looking at the problem itself. How do I know that this is a compound interest problem, right? Why didn't I give you the simple interest formulas here? Well, if you look at all of the parts, A, B, and C, we have the word compounded, compounded, compounded. Okay, so whenever you see that keyword compounded, you know you're going to be looking at the compound interest formula, not the simple interest formula. So let's look at this interest formula. We have A equals P times 1 plus R over N to the NT. So what do all the things mean? So A stands for amount, but we also discussed that this is called the future value. So A is the amount that you're going to have in the future after all the interest has been earned. Okay, so that's kind of the future value. P, on the other hand, is what you put in to start with before there's any interest. Okay, so you're going to start with P, and then it'll earn interest, and once you've kind of added in all the interest, right, then you end up with A. So P is the starting value, A is the ending value. R is the interest that says the rate of interest, and that's the rate per year. Okay, and also notice that in these problems it's called the APR, the annual percentage rate. So this APR is equal to what's R in our formula. Okay, so annual percentage rate, that's R, and that's the rate of interest per year. Okay, N is the number of times per year that interest is compounded. So for example, if you are compounding quarterly, right, that means once every quarter of a year, so that's 4 times per year. So N would be 4. And T is the time in years. Okay, so I think probably this arrow is missing, but it's not NT that's the time in years, it's just T itself, that's the time in years. So NT ends up being the number of compounding periods, right? If you do something, let's say, 4 times a year for 5 years, how many times did you do it? You would multiply 4 times 5, you did it a total of 20 times. So if you do something N times a year, right, and that something is get interest, for T years, right, the total number of times actually ends up being NT. So that's the N times T. But what you need to remember is that T is the total time in years. Okay, so let's look at part A, and we'll just kind of go through as we go through. You deposit $12,000 in a savings account. So before we even move on, you're putting $12,000 into the account. That's what you put in at the start. It hasn't earned any interest yet, but you just put in $12,000. So that's going to be your P. Okay. At an APR of 2%. Well, remember we said that APR is your rate, your interest rate. So right now I'll just write it as 2%, but we are going to have to change that from a percent to a decimal. Then it says compounded monthly. Okay, compounded monthly. That's telling us how many times per year it's compounded. Well, monthly means once a month. There's 12 months per year, so monthly is going to give us an N of 12 times per year. How much money will you have after 7 years? Well, so we see the 7 years, right? So that's the time in years, right? So it's going to be accruing interest for 7 years. So, oops, I don't know what that is, but T equals 7. And what they're looking for is A. It says, how much will you have? Right? That's how much money is there in the future. Okay, so that's the A that they're looking for. Okay, now there's one more thing that we have to do before we're ready to plug into our formula, and that's change R from a percent into a decimal. Okay, so let's do that. So 2%, to change that into a decimal, remember we have to move the decimal place over 2 units. So right now this is the decimal place is right here, because you can think of it as like 2.0. So it's going to move over 1, and then another one. In order to kind of make room for it to move over again, right, you have to add in a 0. Okay, so I'm going to use a different color. So the decimal place kind of moved from here to there. So 2% is 0.02. Okay, so now that all of that's plugged in, now that we have all of our numbers, we're ready to actually go ahead and plug in. So let's write A equals 12,000 times 1 plus 0.02 2 over 12 to the 12 times 7. Okay, so now if we plug this into our calculator, just a couple of notes about order of operations. So the first thing is that the 12 times 7, even though there's no parentheses on it, right? You may have remembered from order of operations when you were in whatever grade that you do exponents before multiplication. But if there's a multiplication inside the exponent, right, the 12 and the 7 are both inside your exponent, you need to actually multiply that out first before you do any exponentiation. And also just remember that division comes before addition, so you want to do this division before you do the addition. So those are the first two things that I personally would do. I would do, I mean, it is possible to do this thing all at once, put it into your calculator, make sure you use your parentheses correctly, right? No problem. If you're comfortable doing that, go for it. If you're not, if you really, want to kind of do it step by step, kind of the first two things that I would do is this division and this multiplication. Okay, so putting the division into my calculator, what I'm getting is A equals 12,000, I haven't changed this, 1 plus, and then when I put 0.02 divided by 12 into my calculator, I'm getting 0.0016666, sorry, so these ones are zeros, and these ones are sixes, that was unclear, and let's put a 7 there. So notice I did not round very much when I did this, right, because even if you want to kind of round your final answer, you could, once you do, when you apply your exponent, kind of small errors will end up compounding. So you don't really want to round very much until the very, very end. Okay, so that's what I got for this division, right? So 0.02 divided by 12, I got 0.00166667. So now let's do this exponent. So 12 times 7 is 84. Okay, so 12,000 times 1 plus 0.00166667, all to the 84. Okay, so now let's just think about our order of operations. We're going to do inside the parentheses first. So since this addition is inside the parentheses, we're going to do that first. So we get 12,000 times 1, sorry, I'm doing the addition, so let me just erase this. Right, 1 plus 0, right, you just get 1.0016667. I may have added a couple more sixes in there, but it's really 0.666 repeating, right? So the 7 was just rounding off, okay? And then I still have to the 84th power, okay? Now, in terms of the order of operations, I'm going to do my exponent before, let me just move this onto the next screen. Okay, so A equals 12,000 times 1.00166667 to the 84. You want to do your exponent before you do the multiplication, okay? And one trick to realizing if you made a mistake in this step or in another step is that you're not going to get things that are astronomically huge, okay? Sometimes when you raise a number to the 84th power, you can get an error on your calculator if if the number, you can get something huge if you raise the wrong number to the 84th power. Okay, so if you are getting an error on your calculator at this point, this is a good place to check and see if you made a mistake. Because the thing that's being raised to the 84th power should be close enough to 1 that you don't get something really huge. So if you made a mistake earlier, or if you multiply by the 12,000 first, or various mistakes, right, you're going to end up with something really, really, really big. Okay, and you don't want something really, really big. Okay, so this should just be 1.0016667 to the 84th power. So what I got, and when I put that into my calculator to the 84th power, I just got 1.150, let's do 14, let's just round it there. Okay, so not super huge, not at all. A little bit bigger than it was, but still less than 2. Okay, so again, if you raise something to the 84th power and it comes out huge, it comes out to be an error, go back and check your work, because this should come out to be a fairly reasonable number, probably between 1 and 2. So then your final step is to multiply that by 1,200. I'm sorry, 12,000. I keep saying 1,200 and I want 12,000. So what I get is I get 13,801 point, let's say 68. And whenever you're dealing with money, it's always good to round to the nearest cent. Okay, and then we go back and then we look at the original problem. We say, does this answer make sense, right? I started with $12,000. I earned some interest. Now I have, a little less than $14,000. Totally reasonable amount. Okay? Okay, so now looking forward to part B. You deposit $12,000 in a savings account at an APR of 2% compounded quarterly. Okay, so everything is the same except for quarterly. How much will you have after 7 years? So before we do anything, if we just want to kind of estimate our answer, the answer should come out pretty similar to the answer in A, which was just around 13,800. If you want to estimate, it's actually should come out to be a little bit lower than in part A because you're not compounding as frequently, right? The more you compound, the more your interest has a chance to earn more interest. So if you're not compounding as frequently, you're going to have a little bit less. So it should come out to be a little bit less than 13,800, but not that much less because all the other things are the same. We're still talking about putting in 12,000, still has an APR of 2%, right? We're still doing it for 7 years. Okay, so we have P is 12,000, just like before. R is, I'm going to go just straight to 0.02. Okay, here, quarterly, that means once per quarter of a year. There's 4 quarters in a year, so N is 4. Notice, right, N is the number of times per year, not the percentage of a year. So I've seen people make mistakes where they make N be a quarter, right? It's how many times per year, so it should be a whole number, generally. And then how much will you have after 7 years? So again, that puts us with a T of 7, and we're looking for A. So putting everything in, A is going to be 12,000 times, you know what, I need more space. Let me just erase this and put my T, oops, what's going on here? T equals 7 up here. Okay, so here's going to be my 12,000. 1 plus R is 0.02 over N, so now I'm dividing by 4 to the NT, so 4 times 7. Okay, so I'm still going to I'll do my division first. So putting 0.02 divided by 4, what that's going to give me is 0.005. So A equals 12,000. 1 plus 0.005, okay? And then to the exponent, 4 times 7 is going to be 28. So now inside that parentheses, right, I got 12,000, 1.005 to the 28. Okay, now again, I'm making sure I do this correctly. I'm going to do my exponent first, and it should not come out to be huge. So 1.005 to the 28 is going to come out to be, sorry, I should have paused. It's going to come out to be 1.14, I'll do 99, okay? And that's going to be times 12,000. So putting that into my calculator, I'm getting 13,798 and 47 cents. Okay, so just as predicted, it's less than our answer for part A, but not by much, right? Part A was a little over 13.8. This is a little under 13.8. Okay, so we're earning just about the same amount of interest, but slightly less because we're compounding quarterly instead of compounding monthly. Okay, so now let's turn our attention to part C. How much money must you deposit today? So remember, the amount that you're depositing today is P, your principal. And we don't know that. That's what they're asking. They're saying how much. So this is going to be that P is actually what we're looking for. That's the variable we're going to solve for. So before in A and B, we were solving for the variable A. Now we're solving for the variable P. Okay? Right, how much money must you deposit today? We want to know what P is. To have $12,000 in 5 years. So ignore the 5 years for a second. $12,000 is the amount that you are going to want to have in the future. So that makes $12,000 your A. In 5 years, that's your T. Let's put it over here. assume you put money in an investment with an APR of 2%. Okay, so R, and I'm going to go right from 2%, I'm just going to go directly to 0.02, compounded quarterly, N equals 4. So we're going to plug into the same equation. Just remember that we plug in A for A, and we don't know what P is, so nothing gets plugged in. So 12,000 equals, P is our variable, right? 1 plus 0.02 over 4 to the NT, so 4 times 5. Okay, so just simplifying here, right, 12,000 equals P. 1 plus, remember 0.02 divided by 4 was 0.005. And of course, you can always put that into your calculator again. Okay, and then 4 times 5 is 20. Okay, so now simplifying inside here. Right, so far things have not really changed, right? 1.005 to the 20th power. Okay, so let me just go on to another screen. Okay, so now I'm going to put 1.005 to the 20th power into my calculator. I'm just simplifying anything that can be simplified. I want to do that first. So 1.005 to the 20th power, right? There's no variables there. I can definitely simplify that. And again, even though I'm raising something to the 20th power, because my base is pretty close to 1, I shouldn't be getting something ridiculous, right? I should just be getting a nice small number, also pretty close to 1. So 1.005 to the 20th is 1.104, so that's a 4, 8, that's 4, we'll do 49, let's round there. Okay, so now is where things change, right? So in the previous step, we could just keep simplifying, but now we don't have anything left to simplify. Sorry, this is very unclear what I wrote. This is a 4, oh, I'm writing in red now, look at that. 4 and 9, okay, and that's a 0. Okay, so now, right, I'm solving for P, right? P is what I ultimately want to know. So what's happening to P? Well, it's being multiplied by this, 1.1049. So in order to get P by itself, I need to divide by that. So I'm going to divide by 1.1049. And if I divide one side by that, obviously I have to divide the other side by it, 1.1049. So what I'm ultimately putting in my calculator for P is 12,000 divided by 1.1049, and that's equal to P because these cancel. And what I get is equal to 10,860.71. So $10,000, $10,860.71. I go back to my original problem and I just ask myself, does this make sense? Okay. Well, the first thing I need to check is that it's actually less than $12,000, right? Because if I'm putting money in now and I want it to be $12,000 in the future and I'm earning interest, right, my money should not depreciate. I shouldn't have less money in the future, right? So I need to put in less than $12,000 now. So that's the first thing I want to check, right? It's less than $12,000, but it's also not just ridiculously low. My $4 is not going to grow into $12,000 in 5 years. Okay, but this is a nice, reasonable answer, right? It's a little more than 1,000 less. Okay, so it's a nice, reasonable answer. So there you go. And I just checked my answer against the sheet, the review sheet, and it looks like my final cents is off. They have a 75 cents here. Actually, I didn't check the other ones, but likely that's because I rounded too soon. Okay, so this 1.1049, I probably should have kept more decimal places there because it's good not to round very much until the very end. So I only kept 4 decimal places there. It's probably a good idea to keep maybe 6 or 7 to really make sure that you get full accuracy in your final answer.